Hi everyone. You might remember that a few weeks ago I made this starter pops pack which was available for download on my Patreon, and it had a bunch of free components that I built as well as some options for further tiers. Now, something I didn't really do so much here was explore the GLSL POP, and what I'm going to do today is show you an additional starter pack that I've been working on for specifically working with GLSL and also accessing some of the mathematic properties of objects like the neighbour pop. I'm going to start out by just kind of highlighting this thing I made previously as a very, very simple example, this boundary acceleration. And actually I'm just going to take that, delete everything else, and view it just so I don't kill my computer. But I'm going to compare it to this version that is made entirely in pops. Let's also just go into our view mode here. Okay, so this is, both are actually made entirely in pops, but this one is using GLSL versus this one, which, as we can see, I have a bunch of commented mathematical processes going on using these math pops or math mix. I'm adding a velocity to my point position, and that velocity has been instanced or initiated using this random. I'm then combining a bunch of math together to fix my acceleration and boundary collisions, where I'm checking based on my minimum and maximum boundaries that I've set, and then doing some math using these longer kind of operations to reflect. And if we kind of go to the actual code for that starter pack, we also have the sketch that I wrote in processing that also does the same thing, and we can see here that actually the whole reflection logic is actually a little bit simpler to think about when we do it in code. So in a lot of ways it might make sense to do this in GLSL versus doing it in math mix pops, where we kind of take lots and lots of steps to do things. Now, this tutorial is more of a show and tell. I'm just going to close this. If you are interested to go through the working here, you can check out that starter pack, which I'll link to on the Patreon. And this section is also free. This section where this specific boundary accelerate is referenced, it's in the first level of the kind of the interesting free components that I think will be useful for you. But let's look now at how we can make this just using GLSL, and we can see that there is a lot less going on in terms of that network. Like, this is quite a lot of steps to do something fairly simple versus this. And this isn't going to be a straight up tutorial today. I'm kind of just going to show you a few things in this network. This will be available for free, this specific example. There's some other examples I'll show you which I'll be putting in the paid for tier of the Patreon, and I'll link to those later as well. But basically what I'm doing here is I'm generating my initial points. So if I press the spacebar, we can see those initial points being instanced. And again, I'm setting a velocity using random, using this set logic. If we were to look in a pop2, we can see that we've got our velocity values there. And then once I've set that velocity, that's a value that I'm going to feed forward and update. I'm plugging it into a feedback, and then everything in this feedback loop between here and this null, so basically just this GLSL and this limit, are being looped, and this is the logic that we have. I also have this cheeky little noise here, which is applying my acceleration values. But let's take a look at that code, and I'll just stick in the text port for now. Like the P5JS code, we can see it's actually super simple. There are a few specific boilerplate things that we will find in the POP GLSL that we might not have come across before. So the first thing that we'll see is it's kind of different to a GLSL top, which we might have been used to working with. The GLSL top is a pixel shader versus this GLSL pop, which is a compute shader. I've got into GLSL a little bit later in my programming / creative coding career, and I can't say I'm super familiar with it. I have got more familiar with it over time as I've sort of experimented and learned to do things that are more optimized and making things that are obviously more useful for me to use and more dynamic. But can't say I'm an expert at GLSL. And for me, kind of switching over, I actually think that the GLSL compute shader, which I haven't really had much experience with, makes a lot more sense, because what we're doing here is we're referencing attributes. So we can see here that this is boilerplate that kind of stays the same, and then we would reference any specific attributes that are coming in, and say we would output PID, and ID is basically index, equals td in underscore p, and this is saying that we are going to access whatever the p value is from this output. Yeah, we're outputting a p value there. That's great. The one thing that we will see is that we are having this error here, so we actually also have to set our output attributes in the GLSL pop, so we actually can see this and feed forward this information. So this is really neat. What we can also do is if I put in a second input and I want to access something, I could access it using logic like this. Let's say just in2 equals td in underscore, and let's say there's a component of this that we want to access. Let's just say we're going to access the p component as well, and we can say p, and if we want to expand on this, because obviously this is two different inputs, we can say 1 0 and also 1 ID, and here we can say 0 ID. So this is just linking to the input index, so the first input, which would be 0, and the second input, which would be 1. And now let's take a look at this error that we have. Okay, yeah, so we also should say something like a vec3 just to define that data type. If I wanted to work with a vec2, it's going to give me an error, but I can access the XY coordinates. And then obviously you can do some more advanced GLSL stuff with that. But I find that kind of really useful, how we can get these attributes into our GLSL compute shader and then do something with them. In terms of this, I've labeled out this code, so hopefully it's fairly straightforward. And what I've got going on here is I have my uniforms. So let's take a look at that. I have just set up uniform vec3s for my minimum boundaries. So for the X, Y, and Z, minus 0.5 and 0.5. And that's set up. I've also set up a dampening factor, which isn't really doing very much, but we could turn it up and we can see that things are going a little bit faster. This is because we're adding in that acceleration value, and we can see that what I'm referencing for acceleration, I'm referencing this index here and feeding that in. So what's going on here is I basically have my position, my acceleration, and my velocity vector. I'm adding acceleration multiplied by this very small value to sort of smooth it out into my velocity vector, and then I'm updating my position with that velocity vector. So basically I'm applying acceleration and then applying the velocity after that acceleration is applied. If I didn't apply any acceleration, so if I just took this off, we'll see that we just kind of go in straight lines. Also, because I'm applying this dampening factor, it's going to even out. So let's change that to 1. It's just going to reverse that vector on the coordinate it collides with. But let's move back. So yeah, this is because I'm applying acceleration. And then basically I can do something very similar to what I was doing here, where I just have my boundary and my constraint for reflecting. So basically multiplying by either a -1 value or a dampened value. I've clamped just to make sure things don't go sort of too far in any direction in terms of these values. And then I'm writing my outputs. And so this is important, is I'm outputting my position and velocity, which is going to be then fed back into that feedback loop and altered. So something that tripped me up a few times is this output attributes tab. So if I, for example, haven't selected to output my velocity, I'm going to come across an error. And this is something that kind of caught me out a couple of times when I was getting started with these GLSL pops. I've added in another limit just at the end here, just to clamp, just because it's not quite as clamped in the GLSL as I wanted, but this is enough to get this effect how I want. And this isn't really an exercise in making something that's an amazing piece of GLSL code. It's more showing you sort of the ways that you can play around with it and just get started, and relating something like this, where we have multiple pops, into something where actually we have very few. I'm going to show you a few other options in this network. So something I was working on recently, which I did a tutorial on, and let's just take a look at that, creating these custom point trails where elements could delete as you added them to the list. And it was inspired by this sketch by Raven Kwok. And basically this system deleted particles and added particles dynamically. So you could have these systems that kind of built a trail and then deleted those trails, which I thought was super neat and kind of super useful. So I have kind of kept playing with this idea. And this is a sort of a augmentation of that. And in this version here, I'm doing this just using standard pops. I'm not using any GLSL. But if you go in, you can see how I'm applying the logic from that code. I've also decided in this instance to use a replicator to make various versions. So this is something that you can go in and sort of explore. But I've also made a version of this that is taking the same sort of code logic, and I'm using GLSL POP to run through that. So we can see here that there's a bunch of stuff going on. This will be available as part of the Patreon too in the component section. And then this section here is just a output kind of render section where I'm doing a few things. And this was super kind of fun to just try and port into a GLSL POP and combine the GLSL POP with some other pops that are available in the palette. And I actually quite like this effect. If I turn off some of these other things, it's going to speed way up. Something else that's going to be available in this component package that I'll be sharing on the Patreon is this circle packing component. And so for this, I've kind of augmented things I've looked at through tutorials from Percolated, specifically this collision tubes tutorial, and also from a recent talk from Darian Brito. In this, what I'm doing is I am using GLSL in tandem with the neighbour POP to basically detect collisions between circular objects. We can see here that things aren't colliding, or they are colliding but they're not overlapping, so this is detecting boundaries and sort of pushing away. But I've also made some additional kind of augmentations where things move in space rather than just being static, and we can also see that when things touch their edges they shrink versus when they don't touch edges they grow. And this can be worked with. You can start out quite simply by just adding different numbers of points and seeing how that system evolves. You can add to the sort of the various parameters and just play around. I haven't labeled this one quite so much, but it's worth playing with. And you can also see how adding different numbers of neighbors changes the quality of your system. So you can see if you have more neighbor connections available, it's going to be better than if you have, say, 2. You can see here there's lots of overlapping and the output is more sort of jerky than if I have lots. So this is something I wanted to share as well. And finally, I have this sort of just random experiment. And this is literally me just sort of improvising with a couple of elements and trying to make something out of it, just messing around. So this is not super refined, but I think it's kind of interesting to see because this often is how I end up making things, which is just playing. And really what I'm doing here is just a few basic GLSL operations that I've sort of learned, so sort of blending things together and doing some sort of sinusoidal things. But I'm mixing these different things together. So I have a sphere here, I'm turning into a bunch of points, and then I'm mixing it with this origin, and then also just kind of manipulating using GLSL. So this is something that's kind of worth looking at. So I've got some uniforms in here as well that are doing various things. But again, like something that just kind of came out of play and I think is really fun and just worth looking at, just because it's interesting to see what you can do when you just sort of start improvising. And for me, I think the point that I start feeling good about a piece of software or a set of tools is where I can kind of start improvising and playing without having to do too much in the way of looking at tutorials or reference sheets. So that for me is something that can really help. You can also switch different geometries in here to create different sort of output effects, which is kind of nice. Not a particularly complex patch at all, but something that's kind of fun to see and to use. This is the POP GLSL component pack. This first one is going to be available in the free version of my Patreon. So this example here, just showing you how to do acceleration and boundary setting in the GLSL POP. These 3 here are going to be available in my component section. I particularly like this one. I think you can do some really nice stuff looking at the logic in here. This also is quite powerful in terms of, especially if you refine it a little bit, I think you could do some very cool collision-based effects. And this is something I'm going to be exploring more and refining as well.